standard UDEs are ready-to-use UDEs. You don't have to do anything special to call them inside Monospost Developer. You simply need to add the necessary expression to your CAM system, and then this expression will be written inside the apt.cl file. Finally, Monospost will read and automatically activate the UDE that you defined in your post processor. There are 8 standard UDEs, predefined in Monospost. Note that these expressions, which are used to activate UDEs inside Monospost, are the ones that are created for Siemens NX. For each CAM system, you will have the same standard UDEs, however, the expressions that activate these UDEs may change in each different CAM. To see the correct expression that you have to use in your CAM system, look at the guides, named as Using UDEs, in the help, which are prepared for each different CAM system separately. You should also check these guides to learn more about these standard UDEs. These guides will tell you how to add UDEs in the correct place in the CAM program, how to deactivate them, how long they will be effective when activated, per operation, or until the end of the program. I will now briefly describe these standard UDEs. Lock Y-axis is used to activate the polar mode, and in polar mode, a linear axis is locked in 3-axis milling operations. When you lock an axis, that axis remains fixed at the 0 position throughout the operation. Instead, the operation is performed using continuous movements of the C-axis. This UDE takes no parameter, and when activated, updates the value of the variable var_state_oppolar to true. In mill turns, we always lock Y-axis in polar mode. And the operation is performed by using +X and C-axis. There are commands in mill turn controllers, which activate polar mode, like G12.1, G112, and transmit. In 5-axis milling machines, you can still lock an axis in 3-axis operations. However, milling machines do not have a specific code to activate polar mode. Therefore, we use our own parametric polar mode. And you can lock either X, Y, or a diagonal axis in milling machines to enlarge your working zone. However, you still have to use the Y-axis term in the UDE to lock X-axis or a diagonal axis. When you lock an axis other than Y, the necessary adjustments are done inside the post processor. Our second standard UDE is rotate table. This UDE is used to rotate the table to a fixed angle when rotary axis 1 is 0. This is used in order to overcome axis limit errors in 3-axis milling operations. All mill turns have limited X and Y axis travels. And sometimes, instead of using lock axis, you may want to rotate the table to a particular angle, and you may want to perform the operation at this fixed rotary table position. This UDE can also be used on 5-axis milling machines to position the rotary table to a fixed angle. This UDE takes one parameter, which is the angular value that defines the new position of rotary table. Our third UDE is select spindle. This is used to activate a spindle in mill turns. This UDE takes one parameter, spindle name. In this parameter, either you can select main or sub spindle. This UDE changes the value of the variables var_state_op_main_spindle and var_state_op_subspindle. When main is selected in the UDE, var_state_op_main_spindle becomes true, var_state_op_subspindle becomes false. And when sub is selected in the UDE, var_state_op_main_spindle becomes false, var_state_op_subspindle becomes true. If you do not use this UDE, the default mode is main. The next standard UDE is 5-axis start. This UDE is used to determine the position of rotary axis 1, or in other words, tilting or nutating axis, on 5-axis machines at operation starts. This UDE takes one parameter, which can be set to either default or alternate. In post-developer kinematics, you already define rotary axis 1 preferred position either as plus or minus. When you select alternate, the opposite of what you've selected as preferred tilting axis position will be active at operation starts. Default is used to cancel the alternate selection. Our next standard UDE is 5-axis rapid. This UDE is very similar to 5-axis start, but the main difference is that, unlike 5-axis start, which affects the first motion at operation start, the 5-axis rapid UDE becomes effective in the middle of the operation. This UDE only becomes active in the middle of an operation when 3 rapid motions are in a row, and UDE affects the second rapid motion in the middle. This UDE accepts one parameter that can be assigned as no change, short dis, or restore. When you select no change, the rotary axis side will not be changed. This means that, if the last rotary axis position before rapid move is on plus side, it continues to stay on the plus side after this rapid move. If the previous rotary axis position is on minus side, it continues to stay on the minus side. When you select short dis, the position of second rapid motion is found by calculating the shortest rotary axis travel distance. When you select restore, what you've selected in 5-axis start UDE will also become true for 5-axis rapid. This means, if you have selected default for 5-axis start, default side will also be active for 5-axis rapid. If you have selected alternate for 5-axis start, alternate side will also be active for 5-axis rapid. The next standard UDE is synchronization. This is used to set the synchronization number on multi-channel mill-turn post-processors. This UDE takes one parameter, which is the synchronization number. By using synchronization number, two NC programs can be synchronized. When this UDE is enabled on both channels separately, the synchronization numbers are added into both NC programs. And when one synchronization number is reached on one NC program, it waits for the other NC program to come to the same synchronization number. This UDE changes the value of the variable var turret synchronization number. Stop is the next standard UDE in Monospos developer. Stop takes no parameter, and it activates format program pause command. Coolant is the last standard UDE. It has one parameter, and this parameter takes several different values, which are different coolant types, and also the off statement to deactivate the coolant. Note that you also have to adjust the enum parameters inside the words coolant on and coolant off to write the M codes that will activate and deactivate these different coolant types. This UDE also activates format coolant on and format coolant off commands.